Hashing algorithms are one of the main cryptographic components to blockchain and cryptocurrency. Although they might seem scary and complex, they're really quite simple to understand. Welcome to CoinTrades, a channel dedicated towards helping you build knowledge and confidence with investing, specifically in the cryptocurrency space. In this video, we'll be breaking down what hashing algorithms and hashes are at a basic level, how they work, what they're used for, and why they're so important. In later videos, we'll be able to apply this basic concept into why they are so essential for blockchains and the cryptocurrency space, so make sure you hit the subscribe button and the notification bell so you don't miss out on any videos in the future. Hashes are more or less simply just a digital fingerprint for data. Since data is unique in its own way, hash functions are a way for us to basically assign and see a unique identifier to some digital data. The representation for this identifier is typically a long sequence of hexadecimal characters, which means numbers 0 through 9 and letters A through F. Depending on which hashing algorithm is being used, means the amount of these characters you'll see in the hash output will vary. What's unique and important to note about hashing though, is that no matter the size of the data that's input into the hash function, it'll always return the same length hash, just with a different combination of those hexadecimal characters. One of the other key components of these digital fingerprint generating hash algorithms is that changing the data only a small amount will completely change the output and create a completely new and unique hash. Let's go ahead and look at a few examples so you can get a feel for what hashes are, what they look like, and how they behave. The Bitcoin blockchain uses the SHA-256 hashing algorithm, which is what we'll be using for reference in this example. SHA-256 stands for Secure Hashing Algorithm with a 256-bit output, which ends up being a total of 64 characters. A SHA hash of the word CoinTrades with a capital C and T results in the hash that starts with 45F65 and ends with BDFF7. Now, if we simply change the capital C to a lowercase c, the new hash output results in a completely brand new hash starting with 6BE09 and ending with 8E626, which is nothing like the original. So hopefully this helps highlight how changing the data fed into the hashing function only a small amount ends up completely altering the hash that we get for output. Keep in mind too that hashes also aren't just limited to text. As we mentioned, any piece of digital data, from songs to movies to programs and more, can all be hashed, since we're simply creating a unique identifier from any piece of digital data. It's important to know that any data of variable length can be fed into a hashing algorithm and get a hash of fixed output. But one of the properties of hashes is that they can't be reversed. This actually means that simply knowing the hashed value of data isn't enough to derive what the data actually is and what data produce that hash or digital fingerprint. When we look at data that has been encrypted, it's possible to decrypt that data and get the plain text values. However, it's impossible to reverse the function and get the dehashed value with hashes. Instead, the only way to know what data produced a certain hash is to figure out hashes from different data until a match is ultimately discovered with the hashed output. I'm sure by now you can probably see how having a unique digital fingerprint for data can be important and useful, but let's start off by looking at it with regards to data integrity. As we saw in the example, hashes will be entirely different for only a minor change, so the only way to get identical hashes is to have identical data. When it comes to cryptocurrency and blockchain, the whole ecosystem is completely worthless without being able to confirm, verify, and prove the integrity of the data that's being transacted. Hashes are what helps the networks and blockchains to achieve this, and in future videos, we'll be doing a deeper dive into how hashes allow that to happen and how they're implemented to provide that integrity and trust component. If you're still unclear on any hash concepts, drop a note in the comments section below and I'll do my best to get back to you and clear things up or provide additional explanations. Overall, the biggest takeaways are that hashes are just unique digital signatures or fingerprints for a set of data. The fingerprint signature can take any type or length of data and give you a fixed output which is irreversible. This digital fingerprint will also be completely different if any of the data is changed. Thus, by doing a comparison between these hashes, it's pretty simple to see if data is identical or if it is different or has been tampered with. I really hope that you've enjoyed learning about this fundamental component in the blockchain and cryptocurrency space. If you did and you like this type of video and format, please hit the thumbs up like button, as it really does a lot to help me keep producing this type of content, and make sure to follow our socials from the links below. Thanks again for watching, and stay tuned for the next video where we'll be discussing what blockchains are and how hashes are implemented inside of them.